So we have this two states. So from the ready, we'll see that from the running, you can get suspended and go back to the ready state, ready suspend state. From the ready state, you can get suspended, and from the blocked state, you can get suspended. So these are the three places or three states from where a process can be suspended. From a running state, from the running state, if an interrupt occurs or from any other reason, you can directly send back to the uh, secondary memory, that is our hard disk. From the ready state, you can send back to the hard disk, and from the blocked, you can send with the hard disk. So now we can see the explanation here. So let's go back to the previous slide. So processor is faster than the input output, so all the processes could be waiting for IO. So basically, sometimes what happened that we have a huge, let's assume we have a huge RAM, we have a huge main memory, we have 100 processes in the main memory, but all of the processes are waiting for the IO devices. So all of them are in the blocked state or the ready state. Okay. So in that case, we have a new process and we have no memory. As I said in the previous as I was saying in the previous slide. So what we can do, we can swap these processes to disk to free up more memory. So this is the main concept behind the suspended process. When swapped process to disk, blocked state becomes suspended state. So from the blocked state, we can actually swap processes and make it suspended. Now, two independent concepts are here: whether a process is waiting for an event, blocked or not, whether a process is swapped out of main memory, suspended or not. So here we have the blocked state and suspended state. Don't confuse them with each other. The new states are blocked, suspend, as I have said, that from the process in the secondary memory and waiting for an event. And another is the process in the secondary memory but is available for execution as soon as it is loaded into the main memory. So ready means it has everything it needs, just it needs the how should I put it? It needs the permission to get loaded into the main memory. And in this one, it is waiting for some event or maybe some other resources. Now, what are the reasons a process can get suspended? So there are actually various reasons a process can be suspended. So these are the main one. First of all, the swapping, the one that we have actually discussed now. Swapping means again that we need to free up some memory. So this is the number one, that the operating system needs to release sufficient main memory to bring in a process that's ready to execute. Number two, other operating system reason. The operating system may be suspended a background or utility process or a process that is suspected of causing a problem. So sometimes it might happen that a process actually not working properly or might be causing some error or some security breach and many other reasons. Okay, in that case, operating system may suspend a process. Even though it's have a memory free, it can suspend a process. Okay. Then we have the interactive user request. Sometimes a user may wish to suspend the execution of a program for purpose of debugging it or in connection of the use of resources. So sometimes a process running properly, you might just decide to close it. Okay. Then we have this timing. A process may be executed periodically and may be suspended while waiting for the next time interval. So I can give a small example. Like you have a software that gets updated. Okay, that needs regular updated. So what we will do, whenever the update function is needed, it gets called in every 10 hours, and rest of the time it is suspended. So there is a small part of the program is actually always going on that I need to actually run after every 10 hours. So in every 10 hours, the event occur and the system gets updated or it checks for update. And you can see this in for many other softwares as well. In your computer, you will see that sometimes they want to update after a certain amount of time. So this is one example of suspension. So the update program or the dispatcher actually gets suspended. Rest of the time, in every 10 hours, it actually can come to the main memory and execute an update. Then we have the parent process. A parent process may wish to suspend the execution of a descendant to examine or to modify suspended process or to coordinate the activity. So the basic termination request. Okay, so we can just terminate or suspend a process. So these are the main reasons a process can be suspended. But the main one is the concept actually came from the swapping to actually release the memory. And then the rest of the cases, they saw that if they use the suspension, the system actually performs more efficiently and more easily. And that's why they actually introduced these other reasons as well. And finally, we are done with the suspension, and we have now that is we call the processes and resources. So basically we know that operating system controls event within the operating computer system. So operating system controls everything. So we have many processes like P1, P2 up to Pn. So all these processes, what they want, some of the process want processor, IO, main memory. Some process only want IO and main memory. Some process might only want main memory. So each process have their own different resource. We have their own different process accounting time, and these different features. They have different type of requirements. Okay, so fundamentally the operating system basically manages all of these resources. We know that we have studied the functions of operating system. Now, the question is to maintain all these resources, like who took which resource for how many time, when this resource will be free. It is actually not an easy task. And to do that, operating system actually needs some kind of structure so that it can control all the process. Like I have this processes, this processes using these resources. This resources will be freed in this time. So we actually need basic and structure so that it can be managed easily and efficiently. And for that, we actually have a process system control structure. So what it is a control structure. What it controls the process system. Okay, so operating system must have information about the current status of each process and resources. So like if you have like 10 printers in your home or in your office, somehow your computer has to know what of these 10 printers is doing, which one is actually using the is being executed, being printed, for how many times it will take before the printing is finished. So then after a new person comes, a new process comes with the printing command, it can say go to this printer, it will actually be finished first. Then operating system constructs and maintain a table of information about each entity. So we will see that how this entity is being formed, okay, and how it works. So first of all, let's look at the general structure of this control table. So as you can see from the general structure is that we have the four main parts. We have this memory table that keep tracks of all the memory. We have this device table that keep tracks of all the devices. We have this file table that keep tracks of all the files, and we have this process table that keep tracks of all the process. And each process table has its own process image, because we have learned about PCB, process control block. So first of all, it has four part. First is memory, second is device, third is file, and fourth is process. The memory table actually keep tracks of how many memory you have left, which process using which part of the memory. So if another new process, if it requires some memory, he can allocate it. Device structure controls the IO devices, which one is in which state, transferring data to which process, and what type of data is transferring. Let's assume you're taking input from a keyboard and you are actually transferring, writing in a Facebook. So it will keep track that this input from the keyboard should go to the Facebook process. Okay, or if you're typing in a Microsoft Word, so it should keep track that this input from the the keyboard should go to the Microsoft Office. Okay, and then you have the file where this file is stored. Okay, there's a huge information about the file, starting from the file name, file size, file write permission, read permission. So we can read the file. Okay, when the file was created, what are the information stored into the file, and so on. We'll actually have another chapter just about file. Okay, then we have finally the process. So we have seen that each process have an image. So one simple example can be that if you compare with the process control block, each process has a name, each process have an ID, each process have an accounting information, and so on. Okay, there are a lot of information they have. So those are need to be stored as well. So this is the general structure of the control table. Now we'll study in details one by one. So what is a memory table? So as you can guess from the name, that memory table is used to keep track of both the main and the secondary memory. That means the RAM. Some of the main memory is reserved for used by the operating system. The remainder of the available are used by processors. So main memory is divided into two parts. One is used for the operating system. So operating system to manage all this information. Okay, you see, to manage all this file table, the resource allocation, it also needs to run, right? And we have studied that operating system have a program called kernel that actually runs all the time. Then we have the graphical user interface and so on. So operating system also needs some space from the memory. Then we have the process that are maintained and on secondary memory using some sort of virtual memory or simple swapping mechanism. So we have actually seen the swapping mechanism in the 7-state model, where we introduced we have introduced the mechanism of swapping the suspended process. Okay, when a process actually sent back to the storage, secondary storage, so that new space can be made for the new process. Then we have finally the memory table must include this following information: allocation of main memory to process, allocation of secondary memory to process. So obviously it needs to allocate memory. This is very simple. Any protection attributes of blocks or virtual memory, such as process may access to shared memory regions. So this one I will explain a little bit. So it is actually 3 types of issues that can happen here. So let's assume that you are process A and you have the memory access from 1 to 100, and I am process B, I have the access of 300 to 400. So one process is 100 to 200, another one is 300 to 400. Okay, so they have the different processes, they have the different space for their work. But if somehow one process tries to access the information of another process, in that case it actually is an intrusion. Okay, so memory table also include the information and the protection related, so that it can protect its memory from another process. And finally, any information needed to manage is in virtual memory. So all the information that you need is here. So this is the task of the memory table. And in the IO table is, as you can guess from the name, IO table manages all the IO devices and channels the computer system. And any given time, IO device may be available or assigned to a particular process. If an IO operation is in progress, the OS needs to know the status of the IO operation, the location in the main memory being used as the source of destination of the IO transfer. So let me explain a little bit this point. First of all, from the definition, I am sure you're clear that IO tables handles the IO devices and their allocations. IO device may be available or assigned to particular process. So let's assume I have a process, I am playing a game. So mouse, keyboard, this will be allocated for my IO device. Finally, we have the, if an IO operation is in progress, where it actually needs to status of the IO operation, like which operation you are doing, why, and then the location in the main memory being used as the source or destination of the IO file transfer. So what type of or what location that is being used as a source. That means if you want to take input from a keyboard or any input devices, this is called source. If you want to give and send something as a from to the CPU, that can be said the destination. So the location in the main memory, that where I want to send the data or from where I can read the data, can be actually stored here. Finally, then we have, after the IO tables, we have this file table. So the file table provide information about existing of file, their location, their current status, other attributes. If you just right click on any file, you'll see there are a lot of things you can actually know about file, starting from whether you want to share the file with your friends. There is a concept called FTP, file transfer protocol. I think you have heard the name. So it manages all the file, it protects the files, okay, and then we can share the file as well. So the file management system, okay, file management system actually, we have the file manager in our mobile phone as well, which actually divides the file into different parts like documents, pictures, so that it becomes easier for us to find. Just imagine if the file manager and was not there, everything will be actually in one place. So that is actually not good. So if you open a folder, then you have the, like you have 1,000 files. From there you have to search. But now what we can do, we can actually sort our files in different categories. So movies are in one category, like images in one category, and so on. Sometimes the detail of its file management is managed by the operating system itself. Instead of file table, operating system do the task itself. And finally, we have this process table. After covering the process table, we'll take a namaz break. So in the process table, must maintain process table to manage the process. This is actually a must. Okay, before proceeding to the discussion of the examination, okay, record first, there must be some reference to the process resources, such as memory, IO files, directly or indirectly in the process table. So in the process table, the problem here is this first part, that there must be some reference to the resources such as memory, directly or indirectly in the process table. So you have to actually refer some of the resources. So we can actually do that easily whenever we're using, like if you're running a program, it automatically gets allocated the resources. Okay, but it has to be mentioned in the file as well. Then the table themselves must be accessible by the operating system and therefore are subject to memory management. So process table, okay, or in a process table we can also have the concept of like how much information we need to have or store or delete and so on, the research topic that we need to focus on, the resources or not the researches. Secondly, how does the operating system know to create the tables in the first place? So basically when the computer starts, we know the kernel start, right? So from the kernel, the operating system must have some basic knowledge about the environment so that it can actually start building a so that it can start building the basic environment that will create the process table, the other tables as well. Like I don't have it here, but in the process, apart from the process table, we actually used other stacks, okay, for different types of purposes. So we'll go back to that later. But for now, what happens? The computer starts, and step by step, the kernel actually starts this process as well. So